Hello, folks. I think it's about time to start the meeting. Looks like they've saved the best for the last. Welcome to the Privacy Pass meeting. Just going to go quickly to the note well, which probably by Friday you've all seen already. So we'll spend just a minute on that. And just a quick, I think we had a meeting note taker pre-signed up, and I see Watson on the call. So I believe we are all set with a note taker. Thank you, Watson. We have a pretty packed agenda, so I'd like to get started. But just real quickly, does anybody have any additions or subtractions from the agenda?
I have a quick comment, Joe. Subodh and I and some of the other people in the drafts were talking about potentially swapping out the last presentation with one that's focused on API implications and metadata. I sent in slides for that very recently. I was wondering if folks would be okay with that. Maybe
yeah, I have your slides, and I think that's a good thing. You're at the end, so hopefully we can give you enough time to go through your material.
Sounds good.
Okay, then let's get started with our first presentation on issuer cardinality.
Hey, can you hear me okay?
Yes.
Cool. Nice. Yeah, so I'm Alex. I'm one of the authors of the Protocol and Architecture draft. And today I'm going to be talking about a specific aspect of the architecture draft around issuer cardinality and how that relates to client unlinkability and privacy pass ecosystems. So next slide, please. So just as a general overview, if you're not familiar with the document, it provides an architectural framework for analyzing how we build privacy-preserving ecosystems around the Privacy Pass protocol. And I say that because the unlinkability requirement, which is that client issuances and client redemptions cannot be linked, is determined by the ecosystem in which the protocol exists, rather than it just being like a cryptographic property of the protocol itself. So the architecture document is kind of similar to like the architecture document used in the MLS working group, and is based around formalizing this, formalizing these ecosystems. So we're currently at the second iteration of the architecture document in this working group, and there have been minor changes in the last iteration around clarifying token metadata considerations, which, as Chris mentioned, is going to be discussed later. Next slide, please. So in this particular talk, I just want to raise a particular issue, which is kind of like still open in the draft, which relates to the number of issuers that are allowed in a Privacy Pass ecosystem, or the issuer cardinality. So the unlinkability of a client essentially rests upon the redemptions that it participates in, because a redemption reveals, if it succeeds, reveals a valid token that the client holds. And so the number of issuers in an ecosystem like transitively leads to the number of different tokens all signed under different keys in an ecosystem as well. And so when a client redeems tokens from multiple issuers, they build like a profile with which they can be linked to, and that client identity is then linked to the anonymity set of clients that possess all the tokens that client has redeemed. And not only that, but there are mechanisms in the Privacy Pass protocol and architecture for clients to redeem tokens via third parties, whereby either redemptions are proxied through a third party to the eventual issuer that verifies the redemption, or via like publicly verifiable cryptographic mechanisms. So next slide, please. So in this scenario, what we're imagining is that there are adversarially controlled issuers, and they're trying to learn the identities of clients. So next slide, please. In the issuance phase, the clients issued tokens, so the clients are these blobs on the left-hand side, and these issuers I1 and I2 issue tokens to some clients. But at this stage, the issuers don't learn anything about the clients other than what is defined at the transport layer of the protocol, which is not something that's currently covered in this working group. The next slide, please. And then in the redemption phase, the clients then redeem their tokens. And this is the crucial stage where unlinkability comes in, because when a client redeems a token with an issuer, it reveals to that issuer that it's been issued a token before. So in this case, client C and client B have redeemed tokens with I1 and I2 respectively. And then next slide, please. So when the adversary then comes to try and make a guess about which client has, when it's trying to link together the issuance and redemption sessions, it can make inferences. So with client C, it knows that either client C was participated in the issuance phase related to client A or client C. But in B's case, there was only one issuance session. So this is like a very synthetic example, but it kind of illustrates how this like unlinkability property is related to redemptions, and how if you can partition clients in such a way, then there is a lot of scope for de-anonymizing clients. So next slide. So in the worst case, each issuer in the system reduces the privacy of the client by a single bit. So this like results in an exponential decrease in the privacy of a client. So next slide. And what's crucial to remember is actually this number of issuers and this privacy decrease is completely independent of any other privacy reducing features. So that can include including token metadata, and also how like key rotations build in. So all these impacts are cumulative in the privacy loss of the client, which can reduce client privacy quite massively, which is something that we're going to talk about on the next slide. Shouldn't have done so many transitions. So section 10 of the document kind of talks about the parameterization of what a generic privacy pass ecosystem looks like. So we have this equation which kind of determines the number of issuers which we can allow. So this like logarithmic expression in the equation relates to the exponential relationship between the number of issuers and the decrease in client privacy. So you have the number of users there, and then like a minimum size of an anonymity set. And then we also build in like you subtract the number of metadata bits which you allow in the protocol, and then you have this over 2 denominator which comes in because of allowing issuers to rotate keys and have 2 active redemption keys at any one time. So next slide, please. And so if we take like a really massive ecosystem, like 1 billion clients, and then an anonymity set size of 5,000, which is currently in the document kind of plucked out of thin air. So if we have some better guidance around what that minimum anonymity set size should be, then that would be useful. We get a maximum number of issuers of 17. This doesn't even allow for any metadata bits. So the more metadata bits you add, then the more you reduce this, like by 1 for every metadata bit. And obviously then if we take a like more smaller ecosystem, so the Privacy Pass browser extension currently only has a number of users in like the hundreds of thousands, I believe, then you're going to have like a much smaller allowed number of issuers. So this is is going to impact the privacy of clients quite considerably, or it's going to impact the practicality of the ecosystem in not allowing many issuers. So next slide, please. So one of the things we've started talking about in the document, but haven't really fleshed out a concrete solution to, is moving the privacy, the unlinkability dependency on the number of issuers to a different property, which can still ensure like a practical ecosystem. So note that privacy bits are only lost when redemptions occur. That's important. So next slide. The alternative option is to reduce the occurrences of these redemptions, or next slide, to limit the number of issuers that a client can redeem tokens for. And so in this scenario, a client would only say hold tokens for 4 different issuers, and so when a redemption is triggered, it can only redeem tokens for those issuers. And then when a client receives tokens from a new issuer, it would drop old tokens off the stack, and in doing so, keep that like small set of tokens. So then, next slide, please. The idea would be that a client at any one time can only redeem a number of tokens for a profile, which is quite limited in its in the number of issuers that it can that it refers to. But the wider ecosystem has many issuers, like as many issuers as you want. But the privacy requirement is moved to the set of tokens that a client holds and the issuers that it infers from that set of tokens, rather than the total number of issuers in the ecosystem. So this I think represents a much more practical way of building a privacy pass ecosystem. But like I said, we don't have a concrete way of doing this. So next slide, please. So I'd just like to finish up here with some potentially obvious open questions around how we would do this. So I mean, how exactly, so these are open questions that I have, and I haven't gone any further in trying to specify this because I haven't come up with a good way of solving them in the discussions I've had with others. But so the key one is how does a client manage which issuers it should interact with, which has been like an ongoing discussion point for a few meetings now. In particular, for example, what happens if a client has a bound on the number of tokens it holds for different issuers? What happens when a client receives tokens from a new issuer? Does it just drop all its old tokens, or could this lead to attacks whereby adversaries could just keep flooding or flushing the client token storage by just sending tokens from new issuers? Around how you build these redemption contexts in which a client holds tokens for different issuers, exactly how would we do that? And I think this is going to be covered in Stephen's talk just after this, where he'll propose a solution at the HTTP layer. And then finally, around obviously there's a question that comes then: are these questions all application specific? Can they all be solved at the HTTP layer? And if so, what architectural guidance in the architecture document is suitable for guiding implementers and constructors of privacy pass ecosystems in making same decisions around this topic? And that's everything I had.
Hi, this is Ben Schwartz as chair. We're only taking brief clarifying questions right now, so we ask that substantive questions and comments be held till the end of this segment. Seeing no clarifying questions, I think we should move to the next presentation.
So following up on that talk, I'm going to talk about idea of introducing these redemption contexts to privacy pass, possibly at the protocol architecture level. Next slide. So when talking about context, I mean places that have shared anonymity and privacy properties. In privacy pass currently, there's this one global context where any redemption identifies that client with every other redemption. We treat it all as one massive context and do all the privacy math there as one massive thing. In the HTTP world, we sort of have this in site boundaries, and top level sites, which are first parties with each other, have their own context, and information shared across different top level sites to some extent exists as a privacy boundary. There are mostly boundaries here, but there are issues such as cross-site information transfer, third-party cookies that introduce complexities here, though there's work to try reducing those sorts of information transfers to make these harder boundaries. In devices, you see these sorts of contexts in applications which have their own information but don't share information between applications, though you also have some leakage here through device identifiers and other fingerprints that allow attackers to see some sort of links between these contexts. Next slide. In the global context case, the problem we have, which Alex mostly covered, is that all these issuers together can build up a massive like fingerprint or ID. In the worst case, you assume that each issuer is one bit of your identifier, and then very quickly you build up an identifier that's enough to identify most users in your space. Next slide. This is mostly a copy of the math that was in the previous one. But like any minimal sorts of values very quickly requires us to limit the number of issuers within this like global context to be a very small number, which introduces centralization concerns and makes the ecosystem very tight and unable to have much flexibility. Next slide. By introducing the concept of these like contexts, you're able to, for the same client, split up how much identifying information is in a specific context using the same, having 8 issuers. Here are the amount of information for each context, assuming like one of these inner squares is like a top level site on the web case, allows you to have all these issuers without leaking quite as much information. Next slide. And the math here is very similar to the global context case, except instead of focusing on the number of global ecosystem issuers, you're only focusing on the issuers that have done some sort of interaction with a context, which can be limited in certain ways by keeping track of like what issuers are present and appear within a context. This lets you keep the global ecosystem pretty wide and like not have too many restrictions on the total number of issuers while still keeping privacy properties, assuming these sorts of self-contained contexts. Next slide. So some of the requirements you actually need to be able to use these sorts of contexts to subdivide our identity spaces, you need these strong privacy boundaries. If there's any way of leaking information from one context to another, you get the issue where over time that leakage is enough to leak all the issuer redemptions in one case to another. And you really need this like strong boundary that redemptions don't affect another context in any way. This includes caching or reusing previous redemptions. And it is true that there are a lot of application-specific challenges depending on the layer, fingerprinting and cross-site tracking. But I think to some extent that's hopefully being solved through these other like application layer things. And while we should take into account that these aren't perfectly leak-proof contexts, I don't know if PrivacyPass is the right layer to try solving or enforcing solutions in that space. Next slide. So to actually add the concept of a context into PrivacyPass, there's a lot of like architectural things that would be useful to talk about how the privacy math looks and the sorts of recommendations based on the size of your context, what your privacy goals are. But there's also some protocol changes that would make it easier to maintain context. In this example, there's the addition of a new layer above redemption that keeps track of what sorts of issuers you're using in particular contexts, using like hard-coded limits that we suggest in the architecture draft to limit how many different issuers get used, and informing people who are trying to develop here that like things like whether or not you have a token, you still need to consider any sort of interaction with an issuer to count against this context. The reason for this is, next slide. So if you just do your context based on like when you successfully redeemed a token, you can do sorts of attacks where you attempt to redeem against a ton of different issuers, and if a user was given a single token from one of these issuers, then the issuer that finally is successfully redeemed leaks more information other than just the like true false of that one issuer, since you also have the fact that that client wasn't given tokens from any other issuer. This unfortunately adds some complexity to the sorts of privacy calculations we need to do, depending on how we implement the counting issuers in a particular context. The straightforward thing is the first issuer you think about and talk to, like you're pinned to that issuer, you either got a token, you didn't get a token, but now like you can no longer try using another issuer in that context. You can increase this number to various amounts to get like 2 to the R, the number of different attempts you're willing to do. And the more attempts attempts to redeem that you have, the lower your privacy in this particular context is. There's alternative ways of counting against your limits, such as just counting the number of individual redemptions themselves rather than caring about the particular issuers that you use. And this gives slightly different math. I think there's even more complexities when you add the number of active keys that a particular issuer can use and the number of metadata bits. And I think a lot of that complexity probably needs to be written down somewhere in the Privacy Pass protocol rather than allowing like each application to try to rediscover its own privacy math here. In the meanwhile time, like you don't want a redemption within a particular context to be stuck forever. Like this is a bad foot gun if like an issuer you decide you don't really want sticks around forever and it doesn't let you switch to other maybe more useful issuers in the future. How we allow a specific context to rotate the issuers that it uses, I think is an open question. There's the never, which is this bad foot gun of like getting stuck with issuers. There's tying it to key rotation, since there's already attacks where an issuer rotates their key and each new epoch represents different data from a previous epoch. And tying it there does allow us to overlap these two problems. There's other more complicated schemes where we try rotating things, but each of them has their own like additional complexity to the privacy math we'd have to do here. Next slide. So some of the open questions are how much of this sort of, I guess, context complication we want to add to the protocol in Privacy Pass, or do we just declare that it's something that each application has to solve on its own? I think if we leave it to the application, this does mean that there's more foot guns in terms of like calculating privacy for each application that has its own definition of a context. And it also means that Privacy Pass would be recommending very small number of issuers, which might not actually be a requirement that the protocol needs if you have these sorts of subdivision of contexts. There's how much the architecture document should go into these various sorts of privacy math and like how detailed we want to go there. And there's an open issue there. There's discussions about how much should be specified about what a context should provide and the sorts of unlinkability guarantees that we need to require, and how to deal with the fact that in the real world we don't really have these like perfectly separate contexts in most cases. And there's how we deal with this issuer stickiness, issuer pinning problem if we, even ignoring like redemption context, it does become a wider issue that needs to be resolved somewhere. I think that's all.
Any clarifying questions? Seeing none, I think we'll move to Mark's presentation.
Thanks. So this is a draft on the centralization problem. Next slide, please. Where this came from, the charter has a milestone on centralization, and here are the words that are in the charter. And I think this actually comes from when the working group was established. There was a lot of discussion about the issue of centralization. And if you add to that what's happened this week, there's a lot of independent conversations going on, for instance, in the plenary and IAB Open. So it's a good time to talk about centralization. And since it's in the charter, it's a meaningful thing to do. I will say that for this draft doesn't take into consideration the idea of redemption contexts. And I'll come back to that at the end, just to say a few words about it. But I think in the 30 minutes that we have to talk about centralization issues, I think that would be a good thing to talk about. Next slide, please. The goal of the draft is really to address the centralization issues surrounding Privacy Pass. It's sort of a supporting piece of documentation for the architecture and protocol drafts. The idea is to identify potential privacy concerns and then try to write a crisp problem statement for PrivacyPass in regards to centralization, and then talk about potential mitigations. And I'll say again that of the potential mitigations, again, redemption context is not in the current draft, although when we come to the end, I'll talk about being happy to add it. Next slide, please. Alex did a great job in the first presentation to talk about what the fundamental problem is. And rather than repeat everything he said, which is what I would do if I spoke from these slides, I'll simply say that one of the fundamental problems in the architecture draft is that we have to really limit the number of issuers. That's a key recommendation of the architecture draft, and it talks about why. I mean, it's actually not just a arbitrary limitation, but Section 10 of the architecture draft talks very specifically about why that limitation is there. I give in this slide sort of the example of losing one bit. What happens is verifiers learn a bit of information for every redemption, right? And so over time, the anonymity of the client is at risk because of that. And so that's one of the reasons why Section 10 of the architecture draft talks about limiting the number of servers in the ecosystem. Again, I will say one more time that this is without the concept of redemption clients. This is in the original concept of what the ecosystem would provide. Next slide, please. So that's a fundamental problem from a centralization point of view, in that if we limit very drastically the number of servers that can provide tokens, then we have a problem where the control of the issuer, the control of the issuance is really centralized in a very, very small number of organizations that would run those issuing servers. And so the natural thing is to wonder whether or not there's an alternative. Steve provided the example of redemption context as one of the alternatives. In the architecture draft, there's another alternative, and that is actually limiting the number of tokens that are at the client. But it seems on analysis, both in Section 10 of the architecture draft and also in the draft here for consolidation, it seems like that's not a very practical alternative. That's not an alternative that would be easy to make real. And the reason for that is here in the last bullet, it implies having significant control over the client. So it's actually much more difficult when you consider the number of clients than it is in terms of restricting the number of servers. Next slide, please. So the problem statement then that's in the consolidation draft actually takes a look at what the architecture document provides as guidance. And so the basic problem statement is that if there's an upper bound available of PrivacyPass servers in the ecosystem, then there's a very practical problem there for deployment of the protocol, because you have a very small number of issuing servers. So you have control located in a very small number of servers. And then we'd call into question who is running those servers and all the usual questions we have about centralization. So having a very small upper limit on the number of servers brings into question traditional centralization problems that are associated not with economic or size of network. It's simply part of the protocol that enforces this problem. And so in the consolidation draft, there's an attempt at a reasonably crisp problem statement. Next slide, please. Now, at the sort of towards the end of the consolidation draft, there's a discussion of what the architectural problems are for PrivacyPass, what the engineering problems are, and what the practical deployment problems are. One of the things that's good about the architecture draft is that the authors of the architecture draft are very upfront about these. It's very clear. And so much of the stuff that's in the consolidation draft simply refers to analytic work that was done when the architecture draft was written. But it's important for it to be in the consolidation draft because it results really in the consolidation problem statement. Next slide, please. The problem is, in the end, that the mitigations in the architecture document don't seem to be mitigations at all. If we limit the ecosystem to a very small number of servers, we have consolidated control of the issuing into a very small group of operators of those servers, right? And then constraining the clients as an alternative doesn't seem to be a solution either. And so what's needed is a mitigation that's consistent with the goals of the underlying protocol, the privacy goals of the underlying protocol, but also address the issue of centralization. Next slide, please. One of the things that this is, of course, a zero draft, so it's the first time it's come to the working group. I'm very interested in comments. I'm looking forward to that. I'm also looking forward to our discussion about redemption contexts and whether or not that's practical. I mean, one of the things I wonder about there is, will the consolidation issue actually be resolved through sort of stratifying the redemption context in the way that was described a few moments ago. Obviously, we will have some discussion now, but I'm looking forward to comments on the list. And that's it. Thanks.
Okay, thank you for the presentations. We now have 30 minutes for open discussion. Please raise your hands and share any comments you have with the group. Christian Whittemore.
Good morning. I have been listening to this presentation, and I have a question for the group. I mean, this problem of anonymity and server knowledge and all that looks an awful lot like the oblivious DNS problem. And the way that oblivious DNS architecture solves the problem is by having several layers of servers. And I could say that as the turtle architecture. So basically the idea is that a client authenticates to a first server and gets a set of tokens. And then using tokens from that set, authenticates to another set of servers and then gets tokens that are not dependent on signaling its own identity. And basically, each time you do this turtle round, you would get some benefits of the server not really knowing who the client is, and thus probably solving the problem in a more robust way. But that's basically a brain fart, so I'm sure people will shoot that down.
Christopher Wood, Chris Wood, do you have would you like to follow up with a response?
I guess a clarifying question. They seem to be like very different problems. That like a privacy pass and oblivious foo, HTTP, DO, whatever. So I think I'm just struggling to see the connection. Like privacy pass at a very high level is effectively like anonymous authorization, whereas ODO, OHTTP, and whatnot are not about authorization at all. Like it's just about hiding sort of the identity of the client. And I guess, yeah, can you like sharpen the comparison a bit more?
Okay, the comparison with obvious DO is that you get two layers of servers. The first layer, in the case of DO, knows the location of the client, but doesn't know the location of the target. The second server knows the location of the server, the target, but doesn't know the location of the client. So each of the servers in this architecture has fractional knowledge of the client identity, or in the case of DO, the client location. And so the idea is that if you have a first round of getting a privacy pass from a set of server, that set of server will have verified the identity of the client and know the identity of the client. And because they know the identity of the client, they can correlate the usage of that identity with usage of tokens later. If you get a second level then, so that basically you go to, once you have your first set of tokens from this first set of server, you go to a second set of server. You don't present an identity, you just present a token that you have observed from the first set. Then that second level of server doesn't know the identity of the client. And because they don't know the identity of the client, they can only it basically washes out the problem.
Chris or Subodh, would you like to reply to that?
I'll give Subodh a chance. I'm still mulling it over.
Yeah, I didn't particularly want to reply to that in any way, but I think the problem might be just the fact that I think this could use a more formal definition of what the problem is, and sort of like in a more formalized way. But I think the problem, if I understand it, comes from the fact that the authorization context might be bound to certain attributes that you might know about, and then like you can join the attributes from multiple sources. So unlike DO and stuff like that, where the linkability actually comes from knowing the IP address of the user, which is delinkified by using third-party proxies, here the linkability comes from the effect of like the fact that you redeem it, you actually have those attributes that essentially the credential or the anonymous token was issued to you for. So I feel like I would love to see a more formalism of this problem, like how this is affected. And maybe some ideas from differential privacy might also be helpful here to reduce the number of like anytime hard cap on number of issuers something comes in, then it ends up being like, I guess, really the failure modes are very unknown or something like that. It would be awesome to like say that we don't need to have a hard cap, but we have like maybe an alternate way to think about it is we have some differential privacy guarantee instead of thinking about like just the number of bits of privacy that we're losing here. Where it's like if we formalize it, maybe we can formalize it in terms of differential privacy as well. Sorry, but yeah, I'm done.
Okay, I'm done.
So Ben Schwartz, hat off. First, on Christian's question, in case it wasn't, in case there's some confusion here, I just want to emphasize that the issuer, whatever it knows about the identity of the client, cannot link that information to the redemption, even when the redemption comes back to the same issuer later. That's the crucial property of blinding that we rely on. So so that step is safe, and the concern is just whether the number of different issuers is sufficient to mark a client somehow. I wanted to focus on the value K that Stephen mentioned in his presentation. In the applications for Privacy Pass that I'm aware of, the goal is something roughly like can we prove that this user is not a bot? And while I don't particularly like that formulation, I think it's a useful shorthand. In that case, it seems to me that if you have a number of trusted issuers, any one of them, ideally, and certainly any small number of them, agreeing that a user is a real user or a non-abusive user, ought to be sufficient. So, for example, if we imagine setting k equal to 1, which in other words means saying that the redemption context, like a website, can only get one positive token and then it's cut off. It can't do any more redemption checks after the first successful redemption. In that case, it seems to me that this math would tell us that instead of 10 issuers, we could have 1 million issuers. And I think that that seems like it would go a long way to addressing the centralization concerns. At k equals 2, essentially saying, as a site, you get to double check. You can check each user against 2 different issuers, and you can try all the issuers you can think of until you find 2 that they support. We're still talking about 1,000 issuers instead of 10. So I wonder if I've understood that correctly and what the authors think of that kind of arrangement.
Looks like Christy's next.
Thank you. I was just waiting to see if the authors wanted to come back on that question, but I'm happy to ask. Yeah, so I'm really glad to see this topic being addressed. Like, I think it's been an issue for Privacy Pass ever since it was suggested it should first be created. So I'm really glad to see it being treated and given the discussion time it deserves. So thanks to everyone who's kind of presented already today. I have a few questions about the anonymity set size. I know it was just chosen to be 5,000. I think even that question is pretty difficult. I don't know if that really is a big enough set size for most people in the group, or if there's a general feeling, and how that affects the rest of the proposals. I think this is such a complex problem. And it's a fundamental issue in Privacy Pass that it may not actually be that privacy, give you that much privacy. When we talk about all of these issues, I think it's a substantial piece of work. To me, it sounds like it's not a simple solution. We don't have a good way of how to solve it right now. So in terms of how the working group works on it going forward, I might just suggest that this is too difficult to try and resolve in a draft, along with the architecture. You may just have to work on it as a separate issue and then merge all of that into the architecture draft. But because there's a lot of potential solutions, all with their varying advantages and disadvantages, implementation difficulty, and yeah, just that question about anonymity set size, as we vary that, what is acceptable? Because 5,000, I know it was acknowledged it's pretty arbitrary, but I mean that I think in itself is a whole discussion. So yeah, thanks.
Thank you, Kirsty. On Kirsty's point, I'll briefly note as chair that we are chartered to describe the risk and possible ramifications of issuer centralization and explore possible mechanisms to mitigate these risks, which is significant, but perhaps not quite the same as must solve it now. Watson?
So I think.
All right, Watson Ladd, Cloudflare. This is kind of very similar to Ben's point, and that is we're talking about clients and issuers, but the redemption process, at least in the applications that I'm most familiar with, is carried out by a website. And that website has an incentive to use very few issuers, because if it's a bot or not decision, it's the weakest link that gets you access. So if it's going to accept a token, it's going to most likely accept it from one place and one token, and then maybe it switches provider and switches somewhere else. So that makes me think that very small values of K are good. And then with sort of Stephen's compartmentalization idea, we're sort of done. There's going to be very few queries. You're never going to see the set of tokens a client has. You're only going to see that it has one or maybe whether it has one or maybe two issuers.
Thank you, Watson. Stephen?
Yeah, so I agree a lot with what Watson said. I guess one of the problems with like setting K equals 1 is like now we've moved the centralization question from like the global ecosystem to like this like specific context ecosystem, but like all sites will probably just choose the same like top set of issuers. So you want to have like some flexibility, like because a site will want to get the best signal it can, and like things on that site will want like their specific choice of issuer. So I don't think like every issuer is like can be swapped out for any other issuer. And I think we still have like a sort of centralization problem here that we need to think about. And I think K greater than 1 is probably required unless we like really are okay with this like permanent stickiness, or think that sites are going to have sufficiently different thoughts about what it wants to try first.
Thank you, Stephen. Chris?
I'm going to actually let Richard go. He was skipped.
Yeah, thanks, Chris. I think I proactively DQ'd myself before I took the mic, so I will DQ myself now. Yeah, I think this seems like a hard problem, and my usual reaction to hard problems is to try and not work on them. So I'm wondering if we can kind of do that here. It seems like a lot of this, we're taking on a huge amount of complexity here by having this like very flexible, very open interoperation between issuers and redemption contexts. Whereas I think the majority of the cases people have in mind have a fairly tight coupling between redemption contexts and issuers, as I think Watson elaborated and put it quite well. So it seems like most of the practical cases have that property. And I also think that even if you have that property, you don't really have a centralization problem. You know, cookies, for example, are specific to a single site. The redemption context for a cookie is tied very closely with its issuance context. And yet, you know, it's a decentralized mechanism. So I'm wary of centralization concerns in the abstract here. I think we can have a flexible, decentralized system that still has a fairly tight binding between redemption context and issuance context, and is able to avoid a bunch of this complexity by not having the openness and flexibility at that level. I glanced at the charter, and all of this should be bracketed by the fact that I'm a bit of a tourist here and haven't been following this real closely, so I may be missing some context. But just glancing at the charter, I didn't see any requirement for that specific level of flexibility. So given that we've discovered that there's this well of complexity here around having flexibility and issuer redemption matching, I would propose that we accept the limitation, avoid the complexity, and keep things simple.
Thank you, Richard. Chris Wood?
I just wanted to follow up on the complexity point. It's not clear to me how what protocol level changes are necessary to sort of constrain or make this sort of constraint that Richard suggests. Because right now it seems like you can instantiate the system in any such way where issuers are different from redeemers, they are the same, and like the core privacy pass protocol specification is basically unaffected. So is the like, do we want to sort of change that such that the protocol constrains having these like decoupling issuing and redemption? And if so, how? But if we don't want to sort of change the core protocol in any particular way, then this just seems like sort of a higher level concern that we should certainly like talk about and document, and like maybe only like focus on deployments that have matching issuers and redeemers. But I'm not sure what like concrete like tangible thing we could do here to either accept Richard's proposal or not, if that makes sense.
Thank you, Chris. Martin Thompson.
Richard's proposal here sounds kind of tempting, but then I think about the point that Watson made, and I'm reminded now that we have these cases where, for instance, you have the bot detection thing, and that's performed by a third party, and so that's been performed on some other site, and the token was issued on some other site, maybe through a third party iframe or something along those lines, and it is still that one single entity receiving that thing. So the framing seems a little bit wrong. So the third party iframe on the redemption site is still the redemption, the relying party becoming the issuer. The thing that I'm concerned with there is that you have potentially a lock-in when it comes to that. And as far as I understand, the only concern that comes from that is the increase in information transfer between those two contexts. And if the number is 2, I don't see that being significantly worse than having 1.
Thank you, Martin. If anybody else would like to comment during this segment, this would be a good time. I know that I asked Chelsea to hold a comment earlier. If you'd like to say it now, this is an allocated time. Otherwise, we'll move on.
Sure. Yeah, I'm happy to do so. We've been chatting a little bit in the chat. One thing I just wanted to point out is with the issuer cardinality question, there might be some nice things that could be leveraged from multi-party signature schemes, noting that the issue of issuer cardinality essentially comes down to signatures being identifiable by the public key that issues them. So I wrote up some notes in the chat, but essentially there's some nice properties of threshold schemes that I think might make this problem easier. It does transfer some overhead to the issuers because essentially then they have to do key management together, but it might make the ecosystem management question easier and also like more constrained as well. So yeah, so I put some notes there. I can follow up with ideas for the authors as well.
Okay, thank you, Chelsea. I look forward to seeing that on the list. Kirsty Payne.
Hi. Yeah, so I just, while we've got a bit of time, I looked at the charter for the group, and one of the things that's got listed as like a deliverable is like a risk assessment for centralization, Privacy Plus deployments for multiple design options. So I didn't know if now might be maybe a good point just to put in folks' heads, like what that risk assessment would include. Like we've spoken about anonymity set size that's reasonable, and like number of issuers, and or maybe this isn't the place for it, but I just wanted to like raise that in terms of how we would also judge the different deployment options and proposals as well. Thanks.
Richard Barnes.
Just wanted to briefly reiterate that even if we had a situation where the redeemer or the relying party had to be the issuer, so we had a one-to-one match, we would not have a centralized system. So this question of flexibility along that axis is independent from questions of centralization. So centralization questions come up much more when you consider the application context in which these frameworks would be embedded.
Thank you, Richard. Let's move on to the next segment.
use cases next. Use case feedback.
Yeah, that's me. I was just wait. Okay, thank you. So thank you for this. My name is Sofia Selli. I'm from Cloudflare, and today I will be talking about a little bit of feedback from the use cases itself of PrivacyPass. So next slide, please. Okay, and just to give a little bit of context of why this presentation exists, mainly because we held at a meeting that was named Anonymous Credential Meeting, and it was co-located on January with Real World Crypto 2021. And the reason why we decided to make this meeting was to actually hear the feedback from the different use cases that had been using PrivacyPass, or some other use cases that are not indeed using specifically as it's written PrivacyPass, but some work that is either derived from it or some different protocol that is based on anonymous credential. And we wanted to hear what specific drawbacks or specific feedback does those use cases have to the PrivacyPass document, or what was missing in the PrivacyPass documents, the 3 drafts that exist there, what was missing and could be potentially looked into or added to. There was a big number of participation. The only problem was that there was a lot of questions for most of the presentations that were given, but there was not much space to actually have a chat around those questions. So that could be a feedback for myself for a new meeting. There was presentation from the Tor project, from Google, from Facebook, from HCAPTCHA, from Brave, and also from the working group that right now we're into. Next slide, please. So what was more of the interesting points that a lot of the presentation touch upon? Some of them have already been discussed in the previous presentations that have been shown today. One of the points was obviously the problem of public and private metadata and how to actually add it into an implementation of PrivacyPass. There's already a lot of proposals around this matter about adding public or private metadata, so I will not go into details around that. But indeed, in the architectural document, there's some mentions around how to add in metadata, but sometimes not as specific enough as the implementation we're actually wanting. So that needs a little bit more work, or at least looking at the proposals that right now exist to add in public and private metadata and decide which one of them which ideas from them could actually be taken into the drafts themselves. Something that was mentioned is that indeed, in general, it was a lot of talking about what kind of attacks can be seen in practice against PrivacyPass. One of them was the attack of hoarding attack, and is this attacking with an attacker collects tokens in a small doses across a large number of clients, and then funnels them into a single spender, and then spends them all at once. This could be potentially prevented if you add some kind of metadata, but it still needs to be addressed in some way into the protocol drafts documents themselves. There were some presentations that also talked about the accessibility concern, and if there's a place on that on the draft. Right now, there's only one mention of the accessibility itself on the architectural draft, I think it is, specifically in the sections that is talking about implementations themselves. Around, for example, what happens is an implementation at the beginning shows this challenge, but this challenge sometimes is down or is really difficult for accessibility purposes. Then, of course, the client accessibility degrades. So there was a question indeed if there could be a section on the draft addressing also this kind of accessibility or talking in general about this. In practical considerations, there was a lot of talking about the double spending storage mechanism. This double spending storage mechanism is basically this database, basically, in which you store all of the tokens that are spent. So you can later check against this storage to see if indeed the token has been spent in the past and you cannot spend it anymore, and sort of try to solve the problem of double spending. In practice, it seems that it's really difficult to implement this double storage mechanism in the safest way. At least that was the feedback. And it's specifically difficult to implement in the case of distributed architecture. There's also some different attacks that can be done into this double spending storage mechanism. So for example, what if the double storage mechanism is down, or if you can do an attack that is a denial of service against this kind of attack, what are the practical implications, the security or privacy implications if this indeed happens? Another problem that it was brought into this meeting is what happens is that you usually have to update this double storage mechanism all the time. What happens in between the time in which the storage is not updated, but a request of updating it is coming? obviously during this X amount of time of updating process, there could be an attack to the overspending itself. So that could be taken into account. Last week we were speaking this with Alex, and one of the things that we decided is to try to put forward a document or a draft that could be later not be thrown directly into a draft, but just a section in the document in which we address this double spending and storage mechanism more directly around the problems that or attacks that you can have into this storage itself, and what kind of properties, what kind of attacks against the properties the privacy pass have could be degraded if this is not implemented in a good way. Yes, another thing that was addressed, and I'm really happy that Stephen already addressed it a little bit, is that a lot of people ask about what would be an ideal key rotation policy. And this is indeed already addressed in the architectural drafts, but a lot of people was asking from an implementation perspective, in their implementation needs, what would be a good key rotation policy. I think it will be really difficult from a draft perspective actually say, like, indeed, this is what your implementation could have. In the draft itself, there's only like very vague statements of what would be a good key rotation policy. And another thing that I was thinking while having this meeting is that it's really difficult sometimes to have reliable mechanisms to measure what attacks happen in practice. So something that one of the Facebook presentation actually showed is that there's not much attacks against token key reusage. So maybe that's not seen in the wild, but it's not to me that much clear if this is not happening in the wild that much because people have not found out that this attack is possible to be done, or just indeed that this is not happening in the wild. So maybe a good measurements would be something to put into place. Next slide, please. Okay, so the path forward. It will be really nice, and I know that the architectural draft already has some sections about implementations, but it will be really nice to have maybe more in-depth sections around that, and to take into describe practical considerations in place. Maybe, as I said, it will be also nice to have a section about accessibility, maybe not something to go that much into depth, but at least just mention it somewhere there. Something that was also discussed in the meeting is that there's sometimes difficulty between the different proposals and the different implementations to see what kind of property they are indeed given, if they are given the same unlinkability as Privacy Pass, or what kind of unlinkability, for example, they are giving. We already came together with a group and decided to do something around it that probably in the future will be a SOC paper of the different properties that exist for anonymous tokens, because they're still missing some literature in actually defining what properties does anonymous tokens indeed have. And another path forward would be to have more meetings around the matter. The meeting was really nice because we had perspectives from different parts of people interested in anonymous tokens in general. And sometimes what happens is that what the feedback could be is that other kind of meetings could be too restrictive, and that this meeting was nice because it sort of allowed everybody to have a say in what they're trying to implement. So maybe some other meeting will be nice to have in place. And also to see what other novel applications of Privacy Pass or derivative protocols are out there. Yeah, next slide, please. And with that, thank you very much. If you want to read the notes, they are located there. Yeah, thanks.
Thank you, Sophia. Now we'll move to our next presentation.
Thanks. All right. So this isn't officially a document for this particular working group. It's sort of a document that is applies generally to various protocols that are being looked at and worked on in the IETF, be it Oblivious Dome, Privacy Pass, and whatnot. But given that the topic of sort of consistency of keys, correctness of keys, and discovery of keys is of importance to Privacy Pass, we thought it would be good to present here. So next slide, please. Yeah, so as I said, there's a number of parallel use cases in emerging protocols that require some mechanism to get a key and then figure out that it is authentic. It is like the correct key for a particular service, be it a Privacy Pass issuer verification key, an Oblivious Dome or HTTP encryption key, or in the case of Tor, maybe a relay public key. We want to get these keys and then use them in such a way that servers that see the use of the key can't link it to specific users. This seems to be sort of a common requirement across all of these protocols, and the point of this particular document is to describe sort of these requirements in various ways we could go about building systems for achieving these two requirements. Next slide, please. So to go into the unlinkability problem a little bit, or the requirement a little bit more, imagine you had a system with n clients, and you had a server with a particular key k. And this server somehow delivers its key to one of the clients in this anonymity set. Next slide. And then later on, someone happens to use that particular key, so send some function f of k over to the server. If the server doesn't have any other sort of linking information, like assuming it doesn't have IP addresses or whatever, perhaps a tall order, but bear with me. The server concludes that the key was just used by one of the end clients in this set. And that's sort of the unlinkability, I guess, property that we want. Next slide, please. And this is important because in sort of an alternative world wherein the server gives a specific key K1 to, say, client C1, and then a totally different key to all the other clients. Next slide. You can imagine usage of a particular key to directly reveal which client it belongs to. So in this particular case, client C1 gave server S a function of K1, and therefore link the two together, which is not great. We commonly, I guess, in the privacy pass world, we refer to this as key tagging, but just generally sort of unlinkability is how we're capturing it here. Next slide, please. So authenticity is also important. Imagine, again, similar scenario of n clients, a server, and you have an adversary who's between the clients and the servers. The server publishes some key k, or has some key k that it makes available. And then the adversary, in this particular case, imagine it just happened to swap in its own key, k prime, to this particular case and gave it to one of the clients. Next slide. Usage of that particular key would allow the adversary to potentially learn something that was meant for S. So in this case, like if it's a public encryption key, as in the case of Odo or HTTP, and the adversary is someone that this client did not intend to actually encrypt its message for, the adversary could easily learn information about the client's usage of this particular key, which is not great. So ideally, when a client, oh, yeah, you can go ahead, sorry. Next slide. Yeah, so ideally when a client discovers a key, it's authentic, meaning that it's sort of correct. It corresponds to the right server that the client intended, and that its use of the key is unlinkable from other people who happen to have the same key. And we sort of say in this case that all clients in the same set have a consistent view of this key. So that then the task at hand is to sort of see if we can build like systems and protocols, or what are the properties of systems and protocols that allow us to get a sort of consistency and correctness of these keys. Next slide, please. So we refer to such a system as a key consistency and correctness system, or KESIS. I don't know. Bad with acronyms, I guess. But one of these systems. I guess the particulars of the system vary obviously quite a lot depending on what the threat model is, what sort of like cryptographic dependencies you have, what your trust model is, what PKI you have, how difficult these things are to run operationally speaking, whether or not you have other external dependencies. Like totally varies depending on use case, and so that is to say that there's not right now one size fits all sort of system. Next slide. And so because there's so many parameters, depending on how you tune these knobs and tune these parameters, different systems might naturally fall out. So for example, if you assume like a trusted third party, then perhaps your system for actually getting keys consistently and getting correct keys becomes quite simple for some definition of simple. But if you don't have like a trusted third party, maybe you need to rely on less trusted parties or proxies, or maybe you need to rely on external systems like append-only logs or whatnot. And you could also like vary the cryptographic techniques under the hood that are used to produce like proofs of correctness. You like rely on classical digital signatures, as is probably the most common case here, or perhaps there are other types of cryptography that might be applicable here. Like somehow making novel use of like identity-based signatures or identity-based encryption for these reasons. That's a hat to Ecker. Next slide, please. So I'm going to go through a couple of examples of the different systems that might fall out depending on your trust model and your threat model. Starting with the trusted proxy discovery setup, which is perhaps the simplest one to reason about. In this particular case, there's some Good Samaritan proxy P that all these clients in this set trust. In it syncs with the server to get the key K. Next slide. And then simply gives that key to all clients in the set. Next slide. Oh, shoot, I'm missing an animation. Anyways, anyone, yeah, thanks, Joe. Anyone using a particular key in this particular case then would not leak what specific client got it, because the server doesn't know which client actually fetched it. Everyone went through the trusted proxy to get it. Of course, assuming like, Tor, like IP addresses are not linkable vectors here and whatnot. So next slide. In the multi-proxy case, there's not this, this Good Samaritan trusted proxy that's acting on behalf of all clients. Maybe there are multiple like less trusted proxies or relays in this particular case, R1 to RM, that a client can connect to. And then, next slide. Through these proxies, ask the server for the key. You can imagine, like, say R1 through RM are all connect proxies or something like that. And through these connect proxies, they establish a connection to S, ask for the key, and then check to see whether or not they get back the same view of the key. This seems like it would potentially work. This, from the server's perspective, it makes it more difficult to vend out, client-specific keys, because it doesn't know whether or not it's giving different keys to different clients or different keys to the same client. Next slide. So server could try. So in this particular example, he vends out K prime to the first relay, which is then forwarded back to the client, and the client discovers, I didn't receive the same view of the key for each request, so perhaps there's a problem. Now there is somewhat of an edge case in this particular case where you can imagine the server rotates the key in between queries, such that this is actually not malicious behavior but benign behavior, and the client just got super unlucky. But I think Chelsea proposed this on the list quite a while ago. But there are various ways to work around that, perhaps by like retrying just to make sure that things eventually stabilize. So next slide, please. Right. So if you don't have like a sort of a trusted entity or like a set of proxies through which you can connect to the server, perhaps another model is in which the server publishes the key to a bulletin board or to a database in a particular case. Next slide. And then server or clients fetch this key from this database, assuming no collusion between the database and the server in this particular case. And this database is, it could be one of many things. Perhaps it's, an append-only log like CT. And the clients get proof that it's in the log. It could be the output of like a consensus protocol, similar to the Tor case. And if clients are really concerned about privacy here, they might use some special mechanism to actually connect and fetch the queries or fetch the keys from the database. Or maybe they might use peer or something like that if that was applicable, depending on the size of the table. I guess the important distinction here is that rather than clients directly fetching or servers directly providing keys to some client, either directly or indirectly, they publish their keys elsewhere for clients to fetch. Next slide, please. Yeah, so the purpose of this document was really to allow us to punt on discovery for the other protocols that we need this thing for, specifically ODO and OHTTP, because discovery is a challenging problem, and the specific mechanism will vary depending on, again, on the threat model, on the specific clients and servers in question, and many other things. So we wanted to at least have sort of a common place where we could talk about the different trade-offs and different properties of each variant of the system, and things to consider. So right now, definitely we did not intend this be published as an RFC. It's simply a place to collect a bunch of information and hopefully facilitate conversation and discussion. We'll note that most of the schemes that I kind of just walked through at a very, very high level could be technically deployed without any new technology. So for example, you could use Mask to connect through Connect proxies to get keys. You could, the trusted proxy case requires no sort of new technology. Just use HTTPS to fetch a key from a proxy. And in the external database case, you can imagine repurposing append-only logs. But then I don't want to get into details, I guess, but there are how those logs are audited is a topic of lively discussion. There's some discussion on things like gossip in the channel. So we're not recommending, certainly not recommending any particular thing, just discussing the various use cases. So I guess to wrap up, there's really only, I guess, two questions with the group. First, is this at all useful to you? I mean, personally speaking, it was helpful to sort of just get everything down in a single place, so we could point to specific systems and point to the particular properties that they have, rather than continually sort of talk around it in the context of other protocols. I guess specifically for the privacy pass case here, we're wondering how this document might help sort of either accommodate these types of consistency and discovery protocols and systems, either in the architecture spec or in eventual future deployments of the protocol. So all that is to say, there's no clear goal. We leave this here as food for thought. Certainly welcome to contributions in any form to help improve it. Yeah, and I guess with that, I'll take questions if there are any, or we can move on. I don't know what the forget what.
Thank you, Chris. The next block of time is for discussion of Sophia's presentation, Chris's presentation, and any other topics that people want to discuss in terms of bringing new topics into Privacy Pass, or other next steps that are on their mind that they'd like to see happen in this working group. Christian Wittema.
I mean, I was listening to Sophia's presentation and to the discussion on concentration, and I wonder whether anyone is interested in doing a study of the economics of these things. I mean, what are the flow of revenues that sustain the provision of servers and things like that? I mean, do we have that somewhere? That's it.
Thank you, Christian. Kirsty Payne.
Hi, yeah, I just wanted to pick up on Christian's point. I think that's like a really interesting angle to explore, like the economics behind this. So yeah, I'd be interested. I would certainly review anything that gets written on that. I think it's one question I had just about like the future of the group. We had a good discussion about consolidation and centralization. I didn't hear any kind of concrete actions that were going to come out of that or any sort of avenues for taking that work forward. So I just wondered, did I miss that, or what's the kind of plan now? Thanks.
Alex Davidson.
Hey, yeah, I just also like to reiterate Kirsty's point that we haven't really had like a concrete, solution to kind of like, at least in the architectural perspective, how we would mitigate, these problems around issuer cardinality and issuer centralization. I think Mark's done a really good job with the draft he's written so far, and I'm happy to continue reviewing that. But I think in terms of how we, build like a generic specification for like adding these redemption contexts that Stephen mentioned in his talk to the architecture document, I think it'd be good to hear some more feedback.
Thank you, Alex. Mark McFadden.
Yeah, thanks. Every time I get up to speak, I end up agreeing with Alex. I do think it would be really helpful to get some more conversation going on the idea behind the redemption context. I think that the consolidation draft can be improved as part of that conversation and as part of that discussion. And so I guess what I would intend is to, based on some comments and suggestions that we get on the mailing list, and also the conversation that we have about the context idea, doing a revision of the draft that I wrote. Thanks.
Thank you, Mark. Martin Thompson.
So I really like the redemption concept. When we spoke with Stephen and others a few weeks ago, it completely solved the question for me of centralization, ability that you can narrow down within for any given website. That the number of things that it can talk to is so severely limited. It does require that you accept the concept that there is some information transfer going on. And so for me, the real question comes down to cardinality in terms of the number of issuers and the number of bits that are carried with each thing. So we talked about the private information bit, and we talked about publicly verifiable metadata as well. And so when you combine those things with other things from the context, that's where it gets interesting. So there's some more analysis required in order to work out what the specific numbers are, but I think this is definitely the direction this needs to go. It's much more limited, but I think that's the only way this can possibly work.
Martin, just to follow up in response to that, what is the specific thing you'd like to see happen? I guess either the protocol or the architecture doc to accommodate the redemption context. Like, it's not a protocol level change, right?
No, it is an architectural structuring. I'm not sure that I can turn it into words for you at 4:30 a.m. on Friday. Saturday morning. But the direction that Stephen outlined and what Alex was getting to is I think the sort of thing that we'd want to have in the architecture document. The way that I had imagined this working in the web context specifically, which might help sort of frame it for you, is that any given website nominates a set of token issuers that are able to operate and essentially redeem tokens on that website. And the browser would enforce a limit on the number of third parties that can be listed in that fashion. And so you would have the bot detection or the ad fraud detection or some small number of use cases for which this would work. They would go into a bucket. The browser would police the size of the bucket to say that there's only 2, there's only 3, or some relatively small number of those. And then the website would be able to frame in those third-party origins, and they would be able to invoke an API. Other origins that weren't listed in that list, or if the list were too long, would be blocked, and so they would receive nothing.
Yeah, that seems totally reasonable. I'm just trying to separate out the architectural guidance work that we provide for the ecosystem going forward from the protocol work. So we could definitely work on text for this.
Minor friendly amendment on Martin's point there.
We have a lot of people speaking without stating their names or being in the queue. So please try to at least state your name and stick to the queue if possible.
I'm Richard Barnes, and I think I am in the queue. Minor friendly amendment on Martin's point. It seems like in a scheme like that, where the relying party or the redeemer was stating the trusted issuers, the redeemer could also specify what public keys it trusts for those issuers, which would clear up some of the key consistency stuff here.
Thank you, Richard. Stephen Valdez.
Investigating.
Yeah, Stephen Valdez, Google. Yeah, I think in terms of actionable things, updating the architecture doc to have these sorts of privacy analysis and as a explicit implementation of this, updating the HTTP API to take into account a lot of Martin's points and how we would implement this in that particular world, I think would be good to getting alignment on what sorts of contexts and how this practically works.
Thank you, Stephen. Alex Davidson.
Yeah, I guess based on Martin's points, it seems like we're moving to an architecture, but forgive the dual usage of the term, but where we have a permanent proxied verifier state whereby we have these entities that are always sending tokens to entities that can verify redemptions. So currently in the architecture document, we kind of allow these multiple different ways of redeeming tokens, but it seems like in that scenario we would never have a direct client to issuer redemption, and that's not something I'm particularly wedded to, but I just wanted to clarify that was kind of the direction people are imagining.
Martin, do you want to reply to that specifically?
If you think about this in the web context, there's a site that's operating and is using the fraud detection or bot detection service. I don't imagine that to be the thing that is consuming the token or redeeming the token. It is probably more likely the case that they have code that's framed in or scripts that they load that creates a frame for the third party that has issued the token and would redeem it itself. So there's no proxying, I imagine, in that scenario. It's more a case of the issuer is the redeemer at that point.
Thank you, Martin. Eric Rescorla.
So maybe I'm just not following you properly, but as I understand it, the limitation on the number of issuers is a key part of your suggestion because you want the client to enforce it. What stops the website from providing a different set of candidate issuers to every client?
Martin?
So I haven't run the analysis on that one. but it would have to be the case that you would. Yeah, so I'm not sure. Perhaps Stephen's run the analysis for this one, but it could be that that doesn't matter in that case. Either the site is already able to identify you, and therefore you don't have any additional privacy loss, or there's nothing else there. So I'll let Stephen answer.
Thank you. David Van Cleve.
Hey, Eric, can you just repeat the question real quick, please? Was it whether there could conceivably be like one issuer sort of uniquely identifying each client?
Eric?
That far. I'm just saying, I guess I'm just saying that, like, if we have something which is being, like, so the root of the problem here, like, as far as I understand, is verifying that, like, everyone has a consistent view of, like, what keys are in play. And so it seems like creating a situation where the client enforces a fixed number of first cardinality of keys that it sees is not the same as restricting the total number of keys in play. And so I'm just trying to make sure, like, that we shouldn't recreate the problem. So I haven't thought through either. So, but I'm just, like, trying to understand it.
Thank you, Eric. Stephen Valdez.
Yeah, so continue, like Martin's point is that if the site is able to identify the issuer or the client, then like the ability to choose what set of issuers already, like ahead of time, doesn't matter. I think the important bit is that different sites aren't able to come to like the same set of issuers for a specific client. And I think to be able to do that, you already need some sort of tracking vector, like identification of that user, in which case this extra then being able to choose like particular issuers doesn't add much capability to the client to do this cross-site tracking.
Thank you, Stephen. Watson Ladd.
Sir, I understood Stephen's proposal a little differently, and sort of Martin Thompson's idea, the combination a little differently, which is the site would only be able to interact with tokens it pre-declared. So it would never be able to see what tokens a client had except for the ones that were on the list of issuers it issued. So if it goes through a set and then changes the set, it wouldn't learn any information about the client because it's a different set from the ones it's handed out before, and every client doesn't have the new issuer.
Thank you, Watson. It seems like we've completed our discussion there. I hope the authors will take this feedback and update their drafts to address some of these issues that are clearly of interest to the group. Let's move on.
Yeah, so this is a slight detour from the original agenda, but as mentioned earlier in discussion with everyone, we thought it'd be useful to spend some time discussing how metadata is expressed in the protocol from an API perspective, as well as from, I guess, bits on the wire perspective. There's an issue sort of linked here that captures sort of the general request to accommodate metadata, because currently it's not something we have in the protocol document, although it's discussed in the architecture document. So let's move on. Next slide, please. Right, so there's different types of metadata. Both the client and server can have metadata either public or private. The metadata might also be verifiable or non-verifiable, depending on what type of data it is. And the existing cryptographic primitives that we have allow, or to some degree, different types of metadata. So for example, the VOP reference instruction that PrivacyPass is currently built on does not allow any public data metadata from the client nor server, with the exception of actually using per metadata bit private keys, but that doesn't scale well. We talked about this in the CFRG meeting a bit earlier. The PNB token work from Google, and the trust token is based on permits private metadata from the server side, but only a single bit. And then the recent private stats anonymous token work, which are linked here, permit arbitrary client or server metadata. Doesn't actually say whether or not it has to be the client or server that provides it, only that the server is the one that actually folds it into the computation. I think ideally, what we would like from sort of an API perspective is the ability to accommodate, all variants of metadata, provided that the underlying cryptographic construction supports it, and then applications would constrain exactly how much metadata is possible. So, for example, it would be not great if there were more than 32 bits of public metadata for any of these applications, given that 33 bits is sufficient to track most people in the world. And certainly we want much less than 32, but we don't want to overly constrain, I guess, the API or the protocol to not allow or accommodate future cryptographic schemes under the hood. So next slide, please. This is basically an overview of how the current protocol works. It was previously just a single round issuance request response, but in trying to prepare for other constructions that have 3 messages, specifically like Schnorr blind signature based schemes, we added a sort of an additional round trip that may or may not be actually take place depending on what cryptographic scheme is being invoked. So there's at a very high level 2 flows. The first of which is to get a commitment request and response, and then the second flow, which uses that commitment request and response to get some tokens. And before all of this runs, the client is expected to get the view of the server's public key out of band somehow, somewhere. It could also be transferred in line, but for simplicity purposes, this is how we're describing it. Next slide. So from the client's perspective, seems like there's really only one way or one sensible place to fold in public metadata here, and that is in the generation step. So in asking or requesting the generation of a series of tokens, M tokens in this particular case, the client would provide, its arbitrary metadata, and the specific instantiation might limit how long that metadata is or what its type is or whatever. Next slide. Interestingly, the server has a couple of opportunities to fold in metadata. So, as mentioned earlier, it can use a different key for each variant or each value of metadata. It might express it that way. Alternatively, it might provide the metadata in line as the issuance response is being generated. And so it's unclear exactly where and how we want to accommodate at both of these different slots, but just noting that the 2 different possibilities exist. Next slide, please. Right, so I guess the question for the people thinking about the protocol and the API and trying to build on top of it is first and foremost, like should there be arbitrary support for client-server metadata? That is like unbounded application-defined, cryptographic construction-defined metadata at the API level, and obviously that would be limited by the underlying crypto. And if so, how do we want to accommodate that? Like, what are the functions that we need to touch in order to add these new fields? Secondly, as I've mentioned a number of times, the cryptographic construction underneath constrains exactly what sort of metadata is possible. So in the PNB token case, you can only have a single private bit of metadata, so you can't arbitrarily add any more. But the other variants like private stats and so on are much more flexible and permit more bits. So the question is, should the protocol and sort of the API impose these limits such that it's not left up to the applications to use arbitrary log metadata that would effectively defeat the entire privacy properties of PrivacyPass? And if so, how should it constrain it? Like, what should the length be? I guess finally, for the architecture document in particular, what sort of additional guidance should we put in place around the usage of this type of metadata? There's already some text there around the different flavors of metadata, be it public and private for clients and servers, and whether or not it's verifiable or not. But maybe there's more we can add there, more guidance for applications that are wishing to use this sort of thing. So that's pretty much it. I believe it's in the charter to support metadata, but I'd have to double check. Chairs, do you know offhand?
Yes, metadata is covered in charter. The line is describing the procedure for including small amounts of metadata with issued tokens.
Okay, thanks. So yeah, we I guess we need to iron out what small amount means here, and figure out whether or not that's something you want to bake into the protocol, or just parameterize and let applications choose. So that's pretty much it. Folks have questions, opinions on how we should do this, I'd love to hear it.
Floor is open for questions. Subodh Iyengar.
This is about yeah, I feel like the kind of how the metadata is actually constructed is probably left to the applications, but I think constraining the size of the metadata would require the applications to also supply some sort of mapping table between, so for example, applications that think of metadata as strings. If you say that the metadata is only 10 bits long, or maximum size of metadata is like 16 bits or 32 bits, then applications would have to supply some sort of mapping table from the string metadata to the small metadata sizes, versus like applications using their strings directly as metadata itself. I think that has implications there as well, like when we constrain the metadata size. The other thing is, I think like just constraining the metadata size, although it reduces the amount of sort of overall, like let's say even if we choose 3 bits or 2 bits, it doesn't mean that probably like only one person has actually issued a credential, and that has been 1 bit, that 1 bit of metadata did not protect that one person, but more like, I think that the anonymity set size is kind of like what we should understand here as well. I'm wondering whether kind of some of this metadata should be folded into some of the discussion we were having about anonymity set size and things like that as well. It's like also seems like a really hard problem to solve as well, to define, hey, we want to define like this metadata size is okay, this metadata size is not okay. Then without like arbitrarily, without taking the application into account, it seems like a really hard problem to solve in a generic way. And yeah, that's kind of like a notes, and maybe Richard Barnes has some thoughts on this as well.
Thank you, Subodh. So I have some questions. First, are you proposing adding a network round trip here? Does this add a round trip to the privacy pass issuance process?
Are you asking about specifically metadata, or?
Yeah. So I'm asking, does adding this metadata support add a round trip to the issuance flow?
No, we don't believe it does. You can fold it in quite nicely into the generate and issuance APIs right now, so it shouldn't affect the number of round trips. The additional round trip that you saw, if you can go back to the protocol, Joe, the additional round trip for the commit request is like skipped entirely for like the VOPRF case. It would be skipped entirely for like the PMB token case and whatnot. It's only there to accommodate protocols, cryptographic protocols that require more than 2 messages to actually mint tokens, which is the case for things like blind Schnorr and whatnot.
Okay, thank you.
Yep.
And my other question here is there enough commonality among the cryptographic primitives to share a common API? And I'll give you an example of a concern here. It seems like some of the primitives here support essentially unlimited amounts of client-generated metadata efficiently, and some of them are very inefficient with very large amounts of client-generated metadata. It would impose significant load on the server.
Are you asking if that is accurate? That assessment?
Well, I'm asking. I don't know if that's accurate, and I'm also wondering more broadly, is there enough commonality among these different primitives that they can hide behind a uniform API?
I don't believe so. So say, for example, compare the, I mean, so Bo can probably speak more to this, so maybe I should let him answer. But in the private stats case, in the anonymous token case, you can either fold metadata into the public key such that it does not affect the online issuance flow whatsoever, or you can fold it into the issuance evaluation in real time. And I guess one of the differences between the two is that the client could, in theory, provide an arbitrarily long piece of metadata for the server to fold in. I'm not sure why it would do that, but it could. However, for that particular variant, the performance cost is not bad. It's just like hashing. All it requires is to hash basically this input to a scalar in the corresponding field. So
okay, thank you.
Maybe that answers the question, but maybe Subodh can speak more to it.
Yeah, I think maybe I think we wouldn't want the client to generate arbitrary metadata that the server was not acceptable to the server. Maybe in the part of the config in the initial preparation stage, the server could say like, I support, this is the maximum amount of metadata I support, and the client would, this is how I think it would work. So essentially that would constrain the algorithms that the server might want to use based on like the maximum metadata it is willing to accept. I think that might be how this scheme might work.
Thank you, Subodh. Joe Salloway?
One of the things I think, with respect to the metadata, it would be good to have a better understanding of what the effects of how much the length of the metadata or the number of options of the metadata, the range or whatever of the metadata affects, the privacy properties of the tokens. It's not clear to me what effect that has.
Certainly every bit of metadata. Oh, I'm sorry. Go ahead, Martin.
No, go ahead, Chris.
I was just going to say that, yeah, every additional bit of metadata is a potential, halving of the anonymity set effectively. So we need to make clear, I guess, what the implications are. I don't believe the privacy calculus in the draft right now, in the architecture draft, goes into detail or like accommodates metadata accordingly, but that's certainly something easy we could do.
So I wanted to just point out here that the number of bits of metadata that you provide here can be combined at the discretion of the attacker here, being the server, to be re-identifying, because they have complete control over the value of those bits. And so if we imagine a scenario where there is some amount of, say, fingerprinting information that's available, say 10 bits of those, and we have 3 different issuers that any given context will tolerate, and you have 8 bits in each one of those tokens of metadata, then you're at 34 at that point, and you're already able to uniquely identify any person on the planet at that point.
Thank you,
This
Martin.
has to be very, very tightly constrained.
I think that's definitely true. I don't disagree with the need to constrain it. It's just a question of like, I guess logistically how we constrain it, either in the protocol itself or at the applications that are using it. Make a good point though, that perhaps like I had a box around like sort of the ideal functionality here that is like the tokens that are produced are a function of like all these different flavors of metadata. And like we might be able to fold different types of metadata in different slots in the protocol, but maybe we only want to provide like the server to include public metadata as part of like the key generation step, and only the client should be able to provide metadata during the token issuance step. You can imagine like a crazy scenario where if during the issuance step the client or the server, if it was able to provide public metadata, like somehow puts in like a tracking cookie or something like that in the token. Yeah. So I'm just I think I'm agreeing with you.
Martin Thompson.
Yeah, back again. So the thing that I really don't want to see here is this be completely unbounded and understood, but there are cases where you can potentially put metadata in that's not directly something that the server's got control over, and that changes the calculus slightly. So if the client is willing to carry some information between contexts itself on its own recognizance, say for instance, it wants to do a sign-in process, and the information that's being carried is its identity. Now that's very much identifying at that point, but because the choice is visible to the client and deliberate on the part of the client, then there's no real risk there. I think primarily what we're concerned with here is information that the client doesn't know about that the server provides. And so this pertains mostly to those private bits that have been proposed in the different solutions. Anything the client provides is a little less of a concern.
Thank you, Martin. Subodh.
Subodh, yeah, I think I was going to make the same point. I think there's two types of metadata. One of them is like the client understandable and the client non-understandable. So if the client understands that this is a part of the protocol or this is required, this is actually understandable for the security of the application, then it seems like that's a more reasonable use of metadata versus and then at that point it's like the size might be different. The size, sort of acceptable size might be different, and stuff like that. So I don't, maybe like 32 bits is fine if the client is actually, if the protocol, if it makes meaningful sense for the application protocol to have that 32 bits and the client can understand what those 32 bits are useful for, versus like, yeah. Versus it's just a server blob of data which the client has no idea about.
Thank you, Subodh. Joe, would you like to say any last words for the session today?
No, I'd just like to thank everybody for coming and participating. I think this is a good discussion, and that hopefully we continue the activity on the mailing list to kind of resolve these issues and start getting the drafts into to incorporate some of this discussion. And that's all I have. Any final comments, or we can end a couple minutes early?
Well, I think we'll leave it there. Hope everybody had a good IETF 110.